A spherical balloon with a diameter of 6 meters is filled with helium at 20 degrees Celsius and 200 kilopascals. Determine the mole number and the mass of the helium in the balloon. In the problem, the balloon is said to be filled with helium gas, and the mole number and the mass of helium in the balloon are to be determined. So at specified conditions, helium behaves as an ideal gas. So before we will proceed in solving the problem, we will identify first the given in the problem. So we have here 6 meters as the diameter of our balloon, 20 degrees Celsius as the temperature, and 200 kilopascals as the pressure. We can solve the mole number using the equation. N is equal to PV over RUT. Since we cannot solve this because the volume of the balloon is unknown, we will solve first its volume. So given the formula of the volume of a sphere, we have V is equal to 4/3 pi r cubed. Since the diameter of our balloon is given, which is 6 meters, we will now have the radius of our balloon as 3 meters. So we will now have 4/3 pi, the radius of the balloon, which is 3 meters raised to 3. Plugging this in the calculator, we will now have the volume of our balloon, which is equal to 113.1 cubic meter. So now let's proceed in solving the mole number. So we have here the formula N is equal to PV over RT, where the P is the pressure, V is the volume, and R is the universal gas constant, which is equal to 8.314 kilopascal cubic meter all over kilomole Kelvin. And T is our temperature, which is in Kelvin. So let's plug in this given into this equation. So we will now have 200 kilopascals multiplied by 113.1 cubic meter all over 8.314 kilopascal cubic meter per kilomole Kelvin multiplied by 20 plus 273 Kelvin. So plugging this in the calculator, we will now have the mole number of our helium, which is equal to 9.285 kilomole. So now let's proceed in finding the mass of the helium in the balloon. So given the equation of the mass, which is equal to Nm, where m is the mass, n is the mole number of the helium in the balloon, and m is the molar mass. This m, which is the molar mass of the helium, can be found in the property table in table A1, which is m is equal to 4.0 kilogram per kilomole. So plugging in the values in this equation, we will now have 9.285 kilomole multiplied by 4.0 kilogram per kilomole. So kilomole will be cancelled, and plugging this in the calculator, we will now have the mass of our helium in the balloon, which is equal to 37.14 kilograms.